is a really short section. This will not take long. It's a very short assignment. I bet you'll have your homework done before the end of the period. So we're going to look at adding and subtracting like radicals and multiplying expressions that have radicals. Okay, so first of all, let's just define real quick what it means to be a like radical. Like radicals are just like terms, right? We said that we have two like terms if the variables are the same variables and they're to the same powers, right? Okay, like radicals are similar. In order for two terms to have like radicals, they have to be the same kind of radical, so they have to have the same index. They both have to be square roots, or both have to be cube roots, or whatever, right? And the radicand, whatever's inside the radical, also has to be the same. So in this case, these are like radicals, and so I can add them up. 3 of those square roots of 5 plus 6 more of those square roots of 5 is 9 of those square roots of 5, right? If you wanted to show an algebraic step, you could factor out, you could undistribute a square root of 5 and combine, add the 3 and the 6, right? But you don't have to think of it that way. Just think of it as if the radicals are like terms, then I'm adding up the numbers of those things, right? Why are the bottom 2 unlike radicals and cannot be added? What's going on? One's a square root and one's a cube root. Exactly. Okay, so let's get a little practice and we'll just kind of build up here. So what's that first one going to be? What do you think? How many square roots of 3 do we have there? No? 8 total, right. How come? Because I've got 1 of them plus 7 of them, right? Is 8 of them. Make sense? If I wanted to factor a square root of 3 out of each term, what would be left behind? Well, 1 plus 7, right? I have 8 square roots of 3. Okay? There's an invisible 1 in front of everything, right? Coefficient of 1. Okay, give me thumbs on that. Does that make sense? Okay. How about the next one? 10 times the square root of 2 minus 4 times the square root of 2 is 6 times the square root of 2. Good. The radical doesn't change, does it? We're just talking about the numbers of those. So we'd end up with 6 of those. Okay? Next one. Can I add those? No, I cannot. I can't. They're different kinds of roots. How about the bottom one? Square root of 2? What do you think, Julie? Yeah, I think you're right. I think you're right. What's your gut tell you here?
Do you subtract the inside?
You don't. You don't. Maybe your gut was wrong. I think you. What do you think?
0.
What do you mean 0?
Like, it's not anything.
Well, it is something. It's just that. It just can't be simplified. Why can I not combine those? They're different kinds of, right, they have different radicands. Square roots of 5 and square roots of 3 are different animals. I can't combine those, right? So those stay the same. So the bottom 2 ones, it's not like the answer is it can't be done. It's just that, well, it can't be done. But the answer would just be it would stay the same. There's nothing additional that I can do. I can't combine the terms, okay? So what about something like that? Are those like radicals? They don't look like it. Is it possible that they could be? Yeah, it is, right? It is because they're not simplified yet, right? When I simplify them, it may turn out that they are like radicals. It might turn out that they're not. Right now, they're clearly not, right? But what if I go further? With 20. Okay, now let's think about this. If I make a factor tree out of 20, what's that going to look like? Okay, yeah, I'm going to end up with a 4 and a 5, and the 4 is going to break up into a 2 and a 2, right? So I get a couple of 2s. So what's that tell me? Okay, so what's my outside number going to be? 2, right? Just a 2. And my inside number? 5. Okay, there's another way to think about that. That works. You can always fall back on couples go out, singles stay in. But when you're dealing with small numbers like 20, there's another way to think about that. You just want to think, okay, is there a perfect what's the biggest perfect square factor of 20? Like think about perfect squares. 1, 4, 9, 16, 25. The biggest perfect square factor of 20 would be 4, wouldn't it? Right? So I could split that up into the square root of 4 times the square root of 5, and the square root of 4 is 2, right? How about the biggest perfect square factor of 45? I could make a factor tree, but isn't 9 a factor of 45? So I could make that the square root of 9 times the square root of 5, right? What's the advantage of that? Well, it's a big advantage, right? The square root of 4 is what? 2. And the square root of 9 is, there you go, right? See what I'm saying? Like if you have really big radicans, you definitely want to fall back on a factor tree and do couples go out, singles stay in. But if they're pretty small numbers, you can probably skip that and just think to yourself, what's the biggest perfect square factor of that radican? And then when you're done, I said it was 9 in this case. So I break it up into 9 and 5. Well, then look at that 5 and ask yourself, could I go further? No, you couldn't, right? I'm not going to ever get any couples out of a 5. There are no perfect square factors of 5. Does that make sense? Okay, so it's a little shorter way to think about this than having to go through that whole factor tree process. So then that's going to give us a 2 outside. That's going to give us a 3 outside. So what's my total outside number going to be for that second term? Yeah, because I'm going to get a 2 times a 3 outside, right? And then inside I'm going to get a 5. Okay? So then this gives me 2 times the square root of 5 plus 6 times the square root of 5 is what? 8 times the square root of 5. Yeah. And it's giving us another kind of easier way to think about this. Notice that when I multiply, if I'm multiplying 3 numbers like this, if 2 of them are outside numbers, the outside numbers get multiplied together. What we're going to find is when you're multiplying expressions that involve radicals, you only ever multiply outside numbers together or inside numbers together. They don't mix, right? So for example, what if I had something like this? What if I had 2 times the square root of 3 times 5 times the square root of 7? What's my outside number going to be? It's going to be 10, because the outside numbers multiply to 10. What's my inside number going to be? 21. Because the inside numbers multiply to 21. Now when you do that, when you multiply inside numbers, you want to look at the result and ask yourself, okay, could I simplify that? Are there any couples in a factor tree of 21? No, there aren't, right? I'm not going to get any couples. There are no perfect square factors of 21, so that's all stuck inside the radical. Okay, does that make sense, though, how we're doing that? You multiply outside numbers together separately and inside numbers together separately when I'm multiplying a combination of the two. Okay, make sense? Give me thumbs on that. Up, down, sideways. How are we doing? Okay, okay. All right, let's try another one. Actually, you guys go try one on the board. Go. Okay, that looked pretty good. So we break these up into pieces. So the 75 I could break up into a square root of 25 times the square root of 3, right? Oops. So we're going to get that. And that's going to break up into a negative, I already have a negative 1 out front. That's going to turn into a 5, right? So we get a negative 5 square root of 3 from our first term. What about the second term? Square root of 12 I'd break up into a square root of 4 times the square root of 3. The square root of 4 is going to turn into a 2. So there's my second term. I just get a 2 times the square root of 3. Then the third one's already done. So give me thumbs. Are those all like terms, like radicals? They are, yeah. Negative 5 of those plus 2 of those is negative 3, plus another negative 3 is a total of negative 6 of those square roots of 3, right? Give me thumbs. How we doing? Up, down, sideways. We good on that? All right. Okay, last issue is multiplying. No big deal. In this case, I just would have to just distribute that square root of 5, wouldn't I? Okay, square root of 5 times a 6. Can I combine those? No, because one's an outside number and one's an inside number, right? So I'm stuck. I just end up with 6 times the square root of 5. Okay? How about the next one? Square root of 5 times square root of 50. Okay, now the way they did this, I don't like. We can do this better. They multiplied the square root of 5 times the square root of 50. Those are both inside numbers, which would give me the square root of 250, right? Which I could break down then. There's a way better way to do that. Why wouldn't we simplify the square root of 50 first, right? Be way easier. So what would the square root of 50 be replaced with?
25 and 2.
Yeah, square root of 25, which is what? 5 times the square root of 2. So we would have made that plus, I'm just going to do this. Yeah, I'm just going to do this. I'm just going to replace that square root of 50. I don't want to do it that way. Let's do this. Does that make sense? We're going to change that square root of 50 into a 5 times the square root of 2, right? Okay, now what? Well, we distribute the square root of 5, and we get that. If we distribute the square root of 5 here, what that's going to give us is, I am going to just delete that whole thing. We don't even want that there. Okay, what we want then, when I distribute the square root of 5 to that term, I'm going to get square root of 5 times 5 square root of 2, right? What's that going to give me? What's my outside number going to be? 5, right? Because I've only got one outside number. So I'm going to get a 5, oops. I'm going to get a 5 outside. What's my inside number going to be? 10. Because I'm multiplying, my inside numbers are 5 and 2, and I get 10. Make sense? Okay? And really, that's my answer, isn't it? Because can I simplify the square root of 10? No, there are no couples in that factor tree, agreed? So it's all stuck inside, and those are not like radicals, so I'm done. That's as far as I can go. Make sense? Okay? So we get, I'm going to get rid of, for our notes here, I want this to be clear on the notes, so I just want to get rid of this whole thing. We don't even need that. Okay, make sense? Everybody? Okay. Everybody agree it made more sense to simplify that square root of 50 before we made that radicand gigantic and had to simplify something bigger. Okay? How about this one? What are we doing here? Yeah, I'm just foiling, right? No big deal. I'm just going to FOIL. So if we distribute the square root of 11, what's the square root of 11 times the square root of 3, everybody? Yeah, those are both inside numbers, so I multiply them. So I get square root of 33. Now let's see, what if we distribute the square root of 11 times 2? Yeah, right? I can't mix those. One's an outside number and one's an inside number. So I get a 2 on the outside and an 11 on the inside. Okay? How about if I distribute a negative square root of 7 to a square root of 3? What's my outside number going to be? Negative 1. Good, so I'm subtracting. What's my inside number going to be? Square root of 21. Yeah, because 7 and 3 are inside numbers, so I multiply them inside the radical. And then finally, negative square root of 7 times positive 2. What's my outside number going to be? Negative 2, right? Negative 1 times positive 2 is giving me negative 2. And then my inside number is square root of 7. I only have one inside number. Okay, give me 1 to 5 on that. Is that working? Okay. Okay. All right. You guys go try this one and then we'll talk about it. Distribute, right? So if we distribute the 5 square root of x, first thing we would do is this part, right? We're going to do this. Up here. Agreed? Okay, next thing we do is this. We're going to distribute the 5 square root of x to the negative 3. Multiply those together. So I'm getting 5 times the square root of x times negative 3. I'll put the negative 3 out front. Then what? Then we're going to distribute this negative 4 there, right? So I get negative minus 4 times 6 times the square root of x, right? And then finally, the last one's easy, right? The last one, we're just going to distribute negative 4 times negative 3. And that just gives us, positive 12. Agreed? Everybody good with that? Okay, when I FOIL. Okay, now let's clean these up. What about the red one? What's the outside number going to be? 30, yeah. And then I'm going to get inside. So all this stuff is going to give me 30 times the square root of x squared, but the square root of x squared, you guys already told me, they cancel, right? I just get an x. Okay, so there's my first term. What about the blue term? What's that going to be? Yeah, just negative 15x. I multiply the outside numbers together, I'm stuck with an x inside. Green term, what's that going to be? Yeah, minus outside, if I multiply the outside numbers together, I get a minus 24. Got an x inside, and then I have my plus 12. And then finally, I could just combine like terms, couldn't I? A negative 15 times the square root of x and a negative 24 times the square root of x would add to negative 39 times the square root of x, right? And there it is. This is just kind of messing things up, isn't it? I'm going to get rid of all this stuff for the notes. Okay, make sense? We all good? Go to work.